So in my previous videos, we've spoken about atomic notation and the structure of an atom. Today, we're going to look at how the electrons are arranged in the shells around the nucleus. Before we get there, though, let's do a quick recap on atomic notation and what it tells us about the number of electrons. Now, we've got two numbers in next to our element symbol. The bottom number, which I've given the symbol, the letter rather Z, that is the atomic number. And the atomic number, of course, tells us the number of protons in the nucleus of an atom. But because atoms we know are neutral overall, if we have a certain number of protons which have a positive charge, so 1 plus, for our atom to be neutral, we would need the same number of electrons. Therefore, the number of electrons will be equal to the number of protons. So let's say we have, what element should we start with? Oh my goodness. Let's go boron, okay? Let's have boron with an atomic number of 5, mass number of 11, but we don't really care about the mass number here because all we care about for this particular video are the electrons. So because boron has 5 protons and this is neutral, that means that we also have 5 electrons. So if we think back to our atomic structure, we've got the nucleus in the center. Again, I'm not going to draw out the nucleus because we care about the electrons. And then we have the shells that surround the nucleus. So, and the electrons go in the shells. There are 5 electrons. So now the question is, where do we put those 5 electrons? Do we put them all on the same shell? Do we split them up? And if we do split them up, how do we decide how to split them up? The rule that we use for electron arrangement at GCSE is let's go up here, the 2, 8, 8 rule, which means that a maximum of 2 electrons will be able to fit on the first shell. And by the first shell, we mean the shell closest to the nucleus, so closest to the middle. Then once that first shell is full with its 2 electrons, then the second shell can hold 8 electrons. And then once that second shell is full, then the third shell can hold a further 8 electrons. Okay, so how will we do this for boron's 5 electrons? Well, our first shell closest to the nucleus can hold 2 electrons. I'm going to choose dots. You can also choose crosses. And then now that that first shell is full, our remaining 3 electrons need to go on the second shell. Okay, now where you position those electrons, it actually doesn't matter that much, okay? I like to put them as far away from each other as possible because we know electrons are negatively charged and like charges repel. So we don't necessarily want them to be bundled up together until they have to be, okay? So that's boron. Let's do another example to make sure we've really got it. Actually, maybe let's do a couple. Let's go for magnesium. Yeah, why not? Let's do magnesium. Magnesium, let's have 1224. So again, the 12 here for the atomic number tells us that we have got 12 protons. And because this is neutral, there's no charge assigned to it. That means we've also got 12 electrons. So how are those going to be arranged? Let's put our magnesium here. That's representing the nucleus that I'm not going to draw out completely. In the first shell, of course, we can hold 2 electrons. Now that shell is full. Let's go now to the second shell that can hold a maximum of 8 electrons. Okay, notice when I've got over 4 electrons, I start to pair them up. You do not have to. You can spread those 8 electrons around as far from each other as you want to, or as close together as you want to, as long as you've got the right number. That now gives us 2 plus 8 gives us 10, which means that the final 2 electrons, must go on the third shell. So how do we write out this electron notation for the electron arrangement? So we know how to draw it, 2 electrons and then 3. If we were going to write this, we would say 2, 3. Okay, or sometimes instead of a dot, you'll see a comma, so 2, 3. If we do the same thing for magnesium, 2 on the first shell, and then 8 on the next one, and then 2 on the last one. So 2, 8, 2. Nice and straightforward. Now this works only for your first 20 elements, which means this 288 rule will work for, where's my red pen, will work for hydrogen up to calcium. After calcium, we'll talk about that at A level, okay? But for the first 20 elements, you can use the 288 rule to determine the electron arrangement for any of those atoms. We can also do it for ions, but I think ions needs its own video. So make sure that you have liked, commented, and subscribed so that you are ready when that video comes along. Bye.